Hello, and welcome to this Academy Cloud Foundations demonstration. In this demo, we're going to be discussing Amazon Elastic Block Store, or EBS for short. EBS happens to represent the equivalent of a hard disk to an EC2 instance. It implements what we call block store because once it is formatted and mounted and we begin to use it, the utilization actually happens in blocks. These are the same mechanics that actually are used in regular hard disk as we know them. Your thumb drives and external disk to your existing computers function in a similar way. Amazon EBS will offer persistent storage for Amazon Elastic Compute Cloud. EBS volumes are network attached and persist independently from the life of an instance. So EBS volumes are highly available, highly reliable volumes that can be leveraged by virtual machines through the Amazon EC2 service. They can be used as the boot partition or attached to a running EC2 instance as a standard block device. When used as a boot partition, EC2 instances can be stopped and subsequently then restarted. This is a state that is only available if you're using an EBS volume as the boot drive for that particular virtual machine. Being able to start and stop will enable you to pay only for the provisioned storage resources while maintaining the state of the particular instance. So EBS volumes will offer you great improved durability over an EC2 instance store because EBS volumes are automatically replicated within the availability zone to prevent data loss in the event of a failure. If you want more durability, EBS provides you the ability to actually create point-in-time consistent snapshots of your volumes that are then stored in Amazon S3. These are automatically replicated across multiple availability zones. So these snapshots can be used as the starting point for new EBS volumes and can protect your data for long-term durability. You can also share these snapshots with coworkers or other developers. In this segment, we're going to begin by creating an Amazon EBS volume. And understanding that it represents an external hard disk to an existing EC2 instance, then we navigate to the EC2 service panel. In this panel is where we're going to be able to configure all the EBS volumes. We're also going to be able to see the Amazon EC2 instances that will use these volumes. So let's get there. We are here on the EC2 panel, and we see an EC2 instance type of T3 Micro. It lives in the availability zone US West 2D. This is an important item to actually note because Elastic Block Store volumes actually have a scope of the availability zone. They are replicated for durability. However, that happens within the availability zone in which they live, and it is expected to be the same availability zone as the EC2 instance that will be utilizing them. So we get to see the EC2 instance, the availability zone US West 2D. If we navigate to the Elastic Block Store and we select volumes, we're going to be able to see that this particular EC2 instance already has an EBS volume as the boot volume. This is ACF EBS 1, a total of 8 gigabytes, and the type is general purpose 2. So we first are going to be demonstrating how to create an Elastic Block Store volume. We get to see an existing volume already. And in order to create an additional one, we're going to select the Create Volume button. This is going to allow us to appreciate the different configuration settings that we can choose. On the volume type, we specify whether to use magnetic disk or solid-state drive. Each of these categories actually represent a different use case. General purpose for most cases, provision IOPS for high-velocity input-output per second, cold hard disk drive, throughput optimized in terms of megabits per second, and magnetic standard. It is important to highlight that only solid-state drive, GP2, and solid-state drive, IO1, can be used as a boot volume. In this case, we just select general purpose. For the size, we're going to set it to 10. The availability zone, we noted it earlier, and we're going to create it on US West 2D. Snapshot allows a previous snapshot to be restored onto a new volume, and encryption chooses whether the contents of the volume should be automatically encrypted when stored on disk. So with these settings already selected, we're going to add a tag. Tags are important because they will allow you to categorize your resources as the density of your deployment grows. In this case, we're going to use a name, and for the volume, we're going to call it EBS1. Once we select the create volume, we actually get to be able to see it on the volumes tab. We're going to need to refresh the window, and here we are, EBS1. EBS1 immediately has a state of being available. The next step in the creation of a volume is actually for us to attach it to an existing EC2 instance. We have one already, so that's good news. And we're going to select from the Actions menu, Attach Volume. On the dialog that comes up, we select the instance. There's only one running, ACF EBS EC2. And it's important to note the device name, in this case, dev SDF. We're going to click on Attach. And notice how that actually changes the state of the EBS1 volume to in use. Now, although we have created and attached the EBS volume, we actually need to be able to format it and mount it onto the EC2 instance. And this is usually done through commands that relate to the operating system that is running on that particular virtual machine. And the first item to actually be able to do, we are within the Linux operating system. So we are going to be using the df command. This is going to list for us all of the volumes. We get to see that despite the fact that the additional volume has been created, it's not visible through the df command. It is important now for us to be able to not only define a file system, but also mount it. These are Linux-specific commands. If you're in a Windows environment, the commands will be significantly different. In this case, we're making a file system, call it ext3, and we create it with regards to dev STF. We get to see the result of the make file system command. Now we're going to make a directory in order to define the place in which we will be mounting this particular volume. Finally, the mount command. The mount command will then mount the volume. And we're able to actually examine df-h once again. And we get to see how we have a volume all the way on the bottom, 10 gigabytes in size, on data store. So how do we create a snapshot? Within the Elastic Block Store panel, we see snapshots. We're able to select it and click on Create Snapshot. We select the volume that interests us, in this case, EBS1. We're going to call it EBS2. On the tags, we label it accordingly. And clicking on Create Snapshot immediately begins to create a photograph of this particular block store. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshot are actually saved. Only what is different from the prior snapshot is actually stored. In short, this minimizes the time required to create the snapshots, and it actually saves on storage. Also, this doesn't duplicate any of the data. Each snapshot contains all the information needed to restore your data from the moment when the snapshot was taken to a new EBS volume. In the future, this snapshot can actually be used to create a new volume that will have the same contents as when the snapshot was created. Now, once you have a snapshot, you can restore the Amazon EBS volume from that particular snapshot. So you can create an Amazon EBS volume from a snapshot to clone it or restore your volumes. When you create an Amazon EBS volume based on a snapshot, the new volume begins as an exact replica of the original volume that was used to create it. The replicated volume loads data in the background so that you can begin using it immediately. And Amazon EBS snapshots can also be easily shared among users and copied over to other regions. So let's take a look at how we will do this. We navigate to the snapshot panel. We see one snapshot, EBS2, that has been completed. We select it. And on the Actions menu, we're going to select Create Volume. At this point, you have the ability to actually change the volume type. You also have the ability to change the volume size. In this case, let's make it 15. Now, it's important that for availability zone, we retain the very same availability zone that we have used before. This is the same where the EC2 instance live. This is the same where we just created the second EBS volume. For name, we're going to call it restored volume. We're going to create volume. And go to the Volumes tab. Now we get to see all three of them, Restore Volume, EBS1, and the original. As we did before, we're going to need to attach this restored volume to the EC2 instance. We select the Actions menu and Attach Volume. From the dialog, we select the EC2 instance that we have available and click Attach. Notice how now it says In Use. The sequence of steps now are very similar for the original EBS1. Now note that you did not have to format the restore volume. We're not going to need to do that because the restore volume with a file system prior to mounting it already existed. Now, before we can use this additional storage that we allocated to the EBS volume, we must extend the file system partition in order to be able to utilize the entire size. Notice how we resized it before, so we must extend the file system partition from within the operating system. Now, it's important for you, before extending a file system that contains valuable data, it is a good practice that you create a snapshot of the volume in case you need to roll back the changes. So we're going to be using the lsblk command that is going to show us all of our volumes. We examine also the sizing. Now, in the Linux operating environment, we issue the command resize 2fs. This will resize the actual usability of that particular volume to its corresponding size. When we examine all our volumes again, we get to see now in the sizing, it reflects 15 gigs. Because this is a volume that has been restored from a snapshot, we expect the original files to be there. So we're listing now the contents of data stored to, and we get to see file.txt. This came in straight from the snapshot, and we could look at the contents as a way of verifying that the file is integral, can be read, can be used. So once again, we created a new volume, we attached it to the EC2 instance, we formatted, we mounted. We wrote a file to that particular partition, and we took a snapshot of it. Finally, we restored that snapshot as a separate volume and also increased the size and told the operating system to please use the full size of this new volume. So now we have two items, one 10 gigs, the other one 15. This concludes this Elastic Block Store demonstration. Thanks for watching.
Let's jump into Simple Storage Service, or S3. Amazon S3 is object-level storage, which means that if you want to change a part of a file, you must make the change and then re-upload the entire modified file. S3 stores data as objects in resources that are called buckets. Amazon S3 is a managed cloud storage solution that is designed to scale seamlessly and provide 11 nines of durability. You can store virtually as many objects as you want in a bucket, and you can write, read, and delete objects in your bucket. Bucket names are universal and must be unique across the world. Objects can be up to 5 terabytes in size. By default, data in Amazon S3 is stored redundantly across multiple facilities. The data that you store in Amazon S3 is not associated with any particular server, and you do not need to manage any infrastructure yourself. You can put as many objects into S3 as you want. Amazon S3 holds trillions of objects and regularly peaks at millions of requests per second. Objects can be almost any data file, such as images, videos, or server logs. You get fine-grained control over who can access your data by using AWS Identity and Access Management policies, Amazon S3 bucket policies, and even per-object access control lists. By default, none of your data is shared publicly. You can also encrypt your data in transit and at rest by enabling server-side encryption. Amazon S3 includes event notifications that enable you to set up automatic notifications when certain events occur, such as when an object is uploaded to a bucket or deleted from a specific bucket. Those notifications can be sent to you, or they can be used to trigger other processes, such as AWS Lambda functions. Amazon S3 offers a range of object-level storage classes that are designed for different use cases. These classes include Amazon S3 Standard. It's designed for high availability, high durability, and performance for frequently accessed data. Because it delivers low latency and high throughput, Amazon S3 Standard is appropriate for a variety of use cases, including content distribution and big data analytics. The Amazon S3 Standard Infrequent Access Storage class is used for data that is accessed less frequently, but requires rapid access when needed. Amazon S3 Standard Infrequent Access is designed to provide the high durability, high throughput, and low latency of Amazon S3 Standard with a low per gigabyte storage price and per gigabyte retrieval fee. This combination of low cost and high performance makes Amazon S3 Standard Infrequent Access good for long-term storage and backups, and it's a data store for disaster recovery files. Amazon S3 One Zone Infrequent Access is for data that is accessed less frequently, but requires rapid access when needed. Unlike other Amazon S3 storage classes, which store data in a minimum of 3 availability zones, Amazon S3 One Zone Infrequent Access stores data in a single availability zone, and it costs less than Amazon S3 Standard Infrequent Access. Amazon S3 One Zone Infrequent Access works well for customers who want a lower cost option for infrequently accessed data, but do not require the availability and resilience of Amazon S3 Standard or Amazon S3 Standard Infrequent Access. It is a good choice for storing secondary backup copies or easy to recreate data like the thumbnail version of an image catalog. The Amazon S3 Intelligent Tiering Storage class is designed to optimize costs by automatically moving data to the most cost-effective access tier. For a small monthly fee per object, Amazon S3 monitors access patterns of the objects in Amazon S3 Intelligent Tiering and moves the objects that have not been accessed for 30 consecutive days to the infrequent access tier. If an object in the infrequent access tier is accessed, it is automatically moved back to the standard access tier. The Intelligent Tiering Storage class works well for long-lived data with access patterns that are unknown or unpredictable. Amazon S3 Glacier is a secure, durable, and low-cost storage class for data archiving. To keep costs low, yet suitable for changing needs, Amazon S3 Glacier provides 3 retrieval options that range from a few minutes to hours. You can upload objects directly to Amazon S3 Glacier or use Amazon S3 lifecycle policies to transfer data between any of the Amazon S3 storage and Amazon S3 Glacier. Amazon S3 Glacier Deep Archive is the lowest cost storage class. It supports long-term retention and digital preservation for data that might be accessed once or twice in a year. It is designed for highly regulated industries such as financial services, healthcare, and public sectors. In some cases, these customers need to retain datasets for 7 to 10 years to meet regulatory compliance requirements. Amazon S3 Glacier Deep Archive can also be used for backup and disaster recovery use cases. It is a cost-effective and easy-to-manage alternative to magnetic tape systems. Amazon S3 Glacier Deep Archive complements Amazon S3 Glacier, and it is also designed to provide 11 nines of durability. All objects that are stored in Amazon S3 Glacier Deep Archive are replicated and stored across at least 3 availability zones, and these objects can be restored within 12 hours. Let's look at S3 buckets in more depth. Buckets are logical containers for objects. You can have one or more buckets in your account. You control who can create, delete, and list objects in the bucket. You can view access logs for the bucket and its objects. Also, you can choose the geographical region where your S3 stores the bucket and its contents. In the example shown, Amazon S3 was used to create a bucket in the Tokyo region, which is identified within AWS formally by its region code, AP Northeast 1. The URL for a bucket is structured like the examples. You can use 2 different URL styles to refer to buckets. The path style URL endpoint is normally used when you need to access objects. The virtual hosted style URL endpoint is used when you are using your bucket as a website for static data. Notice the difference in structure. In this example, the object preview2.mp4 is stored inside the bucket. The URL for the file includes the object name at the end of the bucket path style endpoint. When you create a bucket in Amazon S3, it is associated with a specific AWS region. When you store data in the bucket, it is redundantly stored across multiple AWS facilities within your selected region. This means your data is secured even if there is concurrent data loss in 2 AWS facilities. Amazon S3 automatically manages the storage for your bucket while your data grows. You can get started immediately, and your data storage will grow with your application needs. Amazon S3 also scales to handle a high volume of requests. You do not need to provision the storage or throughput, and you are billed only for what you use. You can access Amazon S3 through the console, AWS command line interface, or AWS SDK. You can also access the data in your bucket directly from third-party backup tools. Keep in mind that this type of access is considered programmatic access and will require that you provision a key pair for the third-party tool to be able to connect to your Amazon S3 service. The endpoints that support HTTP and HTTP access must be globally unique and DNS compliant. This means that bucket names need to be all lowercase and contain a combination of only letters, numbers, and dashes. Symbols like exclamation points, ampersands, or periods are not allowed. The flexibility to store a virtually unlimited amount of data and to access that data from anywhere means that Amazon S3 is suitable for a variety of scenarios, including static website hosting. Amazon S3 buckets can serve the static contents of your website, including HTML, CSS, JavaScript, and other files. The high durability of Amazon S3 makes it a good candidate for storing backups of your data. For greater availability and disaster recovery capability, Amazon S3 can even be configured to support cross-region replication so that data in an Amazon S3 bucket in one region can be automatically replicated to another Amazon S3 region. Amazon S3 costs vary depending on the region and the specific requests that are made. You pay only for what you use, including gigabytes per month, transfer out to other regions, and put, copy, post, list, and get requests. As a general rule, you don't pay for transfers in to Amazon S3 or transfers out from S3 going to Amazon CloudFront edge locations within that same region. Consider the following when you estimate the cost for Amazon S3. First, keep in mind that each storage class has different rates. Second, your costs will be determined by the number and size of objects stored in your Amazon S3 buckets. You must also consider the number and type of requests. GET requests incur charges at different rates than other requests, such as put and copy requests. GET retrieves an object from Amazon S3. You must have read access to use this operation. Put adds an object to a bucket. You must have write permissions on a bucket to add an object to it. Copy creates a copy of an object that is already stored in Amazon S3. A copy operation is the same as performing a get and then a put. Finally, consider the amount of data that is transferred out of the Amazon S3 region. Remember, the data transferred in is free, but there is a charge for data transferred out. Thanks for watching. We'll see you in the next video.